In the early morning mist of December 5, 1901, in the historic city of Würzburg, Germany, a child was born who would one day challenge the very core of human understanding. His name was Werner Karl Heisenberg. No one could have known then that this quiet boy, born into a world still ruled by Newtonian certainty, would one day tear apart the comforting fabric of predictability that science had worn for centuries. The dawn of the 20th century was a time of discovery, revolution, and turmoil. Empires were rising and falling, machines were transforming cities, and a new age of ideas was beginning to stir. In that charged atmosphere, a new kind of mind was needed, one that could look beyond the visible world and imagine what lay beneath the veil of matter. Heisenberg's father, Dr. August Heisenberg, was a professor of Greek philology, a scholar deeply rooted in classical wisdom. His mother, Annie Wecklein, came from an academic family as well, and together they nurtured their children in an environment of intellect, discipline, and culture. In their home, education was not a duty, it was a way of life. The young Werner grew up surrounded by books, music, and philosophical discussions that bridged the ancient and the modern. While other children played outside, he was often found reading, questioning, or contemplating the strange mysteries of numbers and patterns. From the very beginning, his world was filled with curiosity. But Heisenberg was not a boy lost in theory alone. He loved the outdoors, the crisp air, the thrill of climbing mountains, and the sense of freedom that came with it. As he grew, so did his connection with nature. He once wrote that the clarity he found in the mountains was the same clarity he sought in his equations. The natural world became both his refuge and his inspiration. Every gust of wind, every shimmer of light on the lake, every star twinkling above him seemed to whisper secrets of a deeper truth, truths that someday he would try to express through the language of physics. In school, Werner stood out not only for his brilliance, but for his independence of thought. His teachers often found him questioning ideas that others accepted without hesitation. He was fascinated by mathematics, drawn to its purity, its logic, and its beauty. Numbers and symbols seemed to him not just abstract tools, but keys to unlocking the hidden harmony of the universe. By the time he reached his teenage years, he had already developed an intense passion for problem-solving, often tackling equations far beyond his grade level. His classmates admired him, though some found his confidence intimidating. He was not boastful, but he carried an aura of certainty that came from deep conviction. Germany at that time was a nation in transition. The old traditions of classical learning were giving way to the explosive energy of modern science. The achievements of great minds like Planck, Einstein, and Bohr were reshaping how people saw the universe. Yet for young Heisenberg, these names were distant lights. He had not yet realized that one day he would stand among them. The outbreak of World War I, when he was just a teenager, brought a sudden shift in the world around him. The war scared Europe deeply, but it also hardened a generation of thinkers who would later rebuild both science and society. When Heisenberg entered the Maximilians Gymnasium in Munich, his academic talents became impossible to ignore. He excelled in mathematics and physics, subjects that spoke directly to his logical and curious mind. But what truly defined him was his restless pursuit of understanding. He was not satisfied with knowing how things worked. He wanted to know why they worked that way. That question, why, became the quiet fire that fueled his life. It was not enough for him to memorize the laws of nature. He wanted to challenge them, to see if they could withstand the weight of his imagination. Outside the classroom, Heisenberg found himself captivated by philosophy. The works of Plato, Kant, and Goethe were not just words on a page to him. They were living ideas that intertwined with his growing understanding of physics. He sensed that science and philosophy were two sides of the same coin, both seeking truth through different means. Later in life, he would often say that the boundary between physics and philosophy was not sharp but fluid, and that the deepest scientific ideas often arose from philosophical reflection. This blending of the logical and the spiritual became a defining feature of Heisenberg's mind. When he entered the University of Munich in 1920, the young Werner was eager to dive into the frontiers of physics. His mentor there, Arnold Sommerfeld, was a brilliant and demanding teacher who immediately recognized Heisenberg's extraordinary potential. Sommerfeld was known for his strictness and depth of knowledge. He had trained some of the best physicists of the age. Under his guidance, Heisenberg learned not just the mathematics of the physical world, but also the discipline and precision that scientific work demanded. Sommerfeld's laboratory became a crucible of ideas, a place where theory met experiment, and Heisenberg thrived in that environment. But his true transformation came when he met Niels Bohr, the Danish physicist whose revolutionary model of the atom had already shaken the scientific world. Bohr's visit to Munich left a deep impression on Heisenberg. Bohr's calm, reflective personality and his philosophical way of discussing physics resonated with Werner's own mind. It was Bohr who opened the door for Heisenberg to Copenhagen, where a new generation of physicists was redefining reality itself. In Copenhagen, physics was not just a subject, it was a living dialogue between minds, a philosophical journey into the unknown. At that time, the old world of classical physics was collapsing. The laws that had worked perfectly for planets and stars seemed to fail when applied to atoms and electrons. Matter, once thought to be solid and predictable, now appeared to behave like waves and particles at the same time. Light itself refused to obey a single identity. It flickered between being a wave and a particle, depending on how it was observed. This was the strange new world of quantum phenomena, and Heisenberg stepped into it with fearless curiosity. But the journey was not easy. Heisenberg often struggled with the contradictions that seemed to emerge from every direction. He spent countless nights in thought, pacing, calculating, and doubting. There were times he grew frustrated, times when the mathematics seemed to defy sense. Yet through that struggle, he found clarity. He learned to accept that nature might not reveal itself in the language of common sense, but through symbols and equations that pointed toward something deeper. During those early years, Heisenberg's character was shaped not only by academic rigor, but by his resilience. He was not afraid of failure or confusion. To him, confusion was a sign of progress, a necessary step toward insight. He had an ability to sit calmly amid uncertainty, to listen to the silence between ideas, and from that silence draw meaning. This patience and intellectual courage became his defining strengths. The seeds of his later discoveries were already being sown. His experiences with Bohr, his grounding in mathematics under Sommerfeld, and his philosophical reflection on knowledge and reality were all converging into something powerful. He was beginning to realize that the microscopic world could not be understood through the same logic that governed the macroscopic. There were patterns, yes, but patterns that shimmered and shifted, refusing to be pinned down. The more precisely one tried to define nature's building blocks, the more elusive they became. It was as if the universe itself was whispering, "You may look, but you will never see all at once." As Heisenberg matured intellectually, his confidence grew, yet he remained humble before the vast mystery of existence. Friends and colleagues often described him as calm, thoughtful, and deeply introspective. He was not one to boast of his brilliance, though everyone around him could see it. His conversations often wandered from equations to ethics, from atomic spectra to the nature of human consciousness. He believed that science was not merely a tool for technological progress, but a spiritual endeavor, a way of aligning the human mind with the cosmic order. The aftermath of World War, I had left Germany in political and social chaos, but within that chaos the intellectual world was thriving. In universities and laboratories, young physicists like Heisenberg, Pauli, and Dirac were rewriting the rules of nature. They were the new generation, the heirs of Einstein, Planck, and Rutherford. But they carried the spirit of rebellion. They no longer believed that the universe could be understood through deterministic laws alone. They sought something deeper, something that acknowledged both the limits of human perception and the boundless creativity of nature itself. By his early 20s, Heisenberg had already begun to publish papers that caught the attention of leading scientists. His insight into atomic theory and quantum behavior was unlike anything seen before. He didn't simply calculate, he intuited. He could see patterns where others saw only chaos. His mind worked like an artist's brush on the canvas of mathematics, shaping ideas that would one day become the foundation of a new physics. Yet through all this intellectual rise, Heisenberg remained grounded in his personal sense of wonder. He still climbed mountains, played the piano, and reflected on the unity of nature and mind. He believed that beauty and truth were inseparable, that the elegance of an equation was not merely aesthetic, but a sign of its correctness. To him, a good theory had to sing, it had to possess harmony, rhythm, and coherence. This union of art and science made him a rare kind of thinker, one who saw no divide between the physical and the metaphysical. He once wrote that the goal of science is not to uncover the ultimate truth, but to refine the language we use to describe it. That humility became his shield against dogma. He knew that every answer opened new questions, and that the universe was far larger than any human theory could contain. Even as a young scholar, he understood that knowledge was an evolving story, not a fixed monument. This philosophy guided his every step, preparing him for the storm of ideas that would soon erupt in the quantum revolution. The young Heisenberg, molded by war, wisdom, and wonder, was now standing on the threshold of a discovery that would redefine reality itself. His early life had been a careful preparation, a silent shaping of mind and spirit for the work that awaited him. He was about to look into the heart of matter, to ask questions that no one had dared to ask before. And when he did, the world of science would never be the same again. By the early 1920s, Werner Heisenberg had become a name whispered in the corridors of European universities. He was young, barely in his 20s, but carried the aura of someone who saw the universe differently. When he walked through the halls of the University of Munich, his mind was already elsewhere, deep in equations, wrestling with invisible particles, lost between thought and possibility. He was not just studying physics, he was inhabiting it. Every formula he wrote, every question he asked, seemed like an attempt to translate the secret language of nature into human understanding. In those formative years, the world around Heisenberg was still recovering from the wounds of war. Germany was a land of broken hopes and economic despair. But inside the universities, amid the rubble and uncertainty, ideas burned brighter than ever. The scientific community became a sanctuary for young thinkers who believed that knowledge could rebuild what politics had destroyed. For Heisenberg, science was not an escape from reality. It was a rebellion against it. Through science, he could find order where there was chaos, beauty where there was destruction. Under Sommerfeld's mentorship, Heisenberg absorbed the mathematical rigor that would later make him one of the greatest theoretical physicists in history. Sommerfeld was a demanding teacher, precise in method and vast in knowledge. He treated physics like a sacred craft, and his students were apprentices in the art of deciphering nature. Heisenberg thrived under that intensity. He spent endless hours solving complex problems, pushing his mind to its limits. But beyond the mathematics, what truly captivated him was the philosophy hidden inside the equations. Every number, every symbol seemed to represent not just a physical quantity but a concept, a piece of reality struggling to reveal itself. To Heisenberg, mathematics was not a cold language, it was alive, resonant with meaning. He once described mathematical formulas as the poetry of logical structure, an expression of how nature might think if nature could speak. It was this poetic intuition that distinguished him from his contemporaries. Around 1922, Heisenberg had the chance to attend a seminar led by the legendary physicist Niels Bohr in Copenhagen. That visit would change his life forever. Bohr's way of thinking was unlike anything Heisenberg had encountered. Bohr did not treat physics as a fixed set of laws, but as an evolving dialogue between experiment and interpretation. To him, knowledge was not absolute, it was relational, shaped by how we choose to observe. These ideas resonated deeply with Heisenberg's philosophical roots. Their conversations were long, intense, and often abstract. Bohr spoke slowly and thoughtfully, while Heisenberg responded with youthful energy and precision. They discussed not only atoms and electrons but also the limits of human knowledge itself. In Bohr, Heisenberg found both a mentor and a mirror, a thinker who understood that science was not just about discovering facts, but about understanding what those facts mean. Returning to Munich after his first visit to Copenhagen, Heisenberg carried with him a new sense of purpose. He now saw the quantum world not as a puzzle to be solved by classical logic, but as a realm governed by its own mysterious principles. It was here that his early intellectual foundation began to crystallize into something truly revolutionary. He spent nights poring over spectral lines and atomic data, trying to reconcile theory with experiment. The atoms refused to behave in any predictable way. Classical models broke down, and even Bohr's own model of the atom, though successful, was riddled with contradictions. For most physicists, this chaos was a source of frustration. For Heisenberg, it was an invitation. He sensed that beneath the confusion lay a deeper pattern, something invisible yet consistent, waiting to be uncovered. In the summer of 1924, Heisenberg was invited to Göttingen, one of Europe's greatest centers of theoretical physics. There, surrounded by minds like Max Born and Pascal Jordan, he found an intellectual home. Göttingen was buzzing with excitement and debate. New ideas about quantization, radiation, and atomic transitions filled every conversation. Heisenberg was in his element. His colleagues quickly realized that his ability to think abstractly, to detach from the physical picture and work purely with relations and numbers, was extraordinary. But even among such brilliance, Heisenberg's thought process was unique. He had an almost mystical way of approaching problems. Instead of imagining electrons orbiting a nucleus like planets around the sun, he preferred to think in terms of quantities that could be directly observed, like frequencies and intensities of emitted light. This mental shift, subtle yet profound, was the seed of the revolutionary idea that would later become matrix mechanics. At night, while others slept, Heisenberg would pace around his small study, covered in papers and equations. The moonlight spilling through the window seemed to mirror his own restlessness. He once wrote in a letter that, to solve the riddles of the atom, one must abandon the images of the visible world. That sentence captured the essence of his growing philosophy. True understanding required letting go of what was familiar. It was not about seeing nature as it appears, but as it is. His health often suffered under the strain. Long hours, sleepless nights, and an unrelenting pursuit of answers took their toll. He contracted hay fever so severe that he had to take a break from research and retreat to the island of Helgoland in the North Sea. It was there, isolated by wind and waves, that his mind finally found clarity. The solitude of Helgoland became the crucible for his greatest breakthrough. Surrounded by the vastness of the sea, he realized that the key to quantum mechanics lay in focusing only on observable quantities. That insight, the idea that the invisible behavior of electrons could be described without referencing their paths or orbits, was the culmination of everything Heisenberg had been preparing for since his youth. His classical training in mathematics, his philosophical curiosity, and his comfort with abstraction all converged into a single flash of realization. He began writing feverishly, filling page after page with numbers and symbols. The equations he produced were strange, even to him, arrays of values that refused to follow the usual rules of arithmetic. Yet they captured with stunning precision the behavior of atoms. He had unknowingly created the foundation of a new kind of physics, quantum mechanics, expressed through matrices. It was a discovery so radical that few could understand it at first, but those who did were awed by its elegance. This was not mere calculation, it was a new way of seeing reality itself. Looking back, it is astonishing to realize how much of this revolution was built on Heisenberg's early intellectual foundation. His upbringing in a home of philosophy and music had trained him to think beyond formulas. His love of nature had taught him to seek harmony rather than control. His encounters with Bohr had instilled in him a respect for uncertainty. Every experience, every influence, every failure had prepared him for that moment of insight on Helgoland. The young man who had once climbed mountains searching for clarity had now reached the summit of thought itself. Yet, even in triumph, Heisenberg remained introspective. He often questioned whether human beings were meant to know such things, whether probing the fabric of reality so deeply was a kind of audacity. But his humility never clouded his curiosity. He believed that seeking understanding was humanity's noblest calling, even if it meant confronting the limits of reason. In the years that followed, Heisenberg's work would shake the scientific world. Einstein, Bohr, Schrödinger, all would grapple with the consequences of his ideas. But the roots of that transformation lay firmly in his early life, the quiet discipline of his youth, the fusion of logic and philosophy, the relentless search for beauty and truth. His intellectual foundation was not built on ambition but on wonder. A wonder that began in the classroom, deepened in the mountains, and blossomed in the solitude of thought. Even as his fame grew, Heisenberg never lost that sense of wonder. He continued to play the piano, finding in music the same patterns that he found in physics. The harmony of sound and the harmony of equations, he believed, came from the same source. Both were attempts to capture the infinite in a finite form. To him, the universe was not a machine but a symphony, complex, unpredictable, yet deeply ordered. When he spoke to students, he often reminded them that science is not about collecting facts, but about seeking meaning. He would say that every true discovery begins with confusion, that uncertainty is not a weakness, but the birthplace of insight. Those ideas were not abstract teachings, they were the lessons of his own life. From a curious boy in Würzburg to a young man challenging the boundaries of physics, Heisenberg's journey was one of courage. The courage to think differently, to accept mystery, and to follow reason wherever it led. As the 1920s drew to a close, Heisenberg's foundational ideas were beginning to spread across the world. Laboratories from Copenhagen to Cambridge buzzed with discussions of his new mechanics. Older physicists were skeptical, but younger ones saw in Heisenberg a new kind of hero, a thinker unafraid of paradox, willing to stand on the edge of the unknown. His calm confidence inspired them. They saw in him not just a mathematician but a philosopher of nature. It is easy, in retrospect, to see Heisenberg's early life as a straight path toward greatness. But the truth is more subtle. His journey was marked by doubt, illness, and isolation. He often questioned his own abilities, feared failure, and struggled to make others understand his ideas. What made him extraordinary was not the absence of doubt, but his ability to transform doubt into discovery. Every obstacle became a lesson, every unanswered question a doorway to a new kind of thinking. In that sense, Heisenberg's early life was a microcosm of the quantum world he would later describe, uncertain, fluctuating, filled with potential. Just as particles exist in multiple states until observed, so too did Heisenberg exist in many roles: philosopher, physicist, poet of equations. Each aspect of his being contributed to the whole, weaving a mind capable of seeing what others could not. By the time he reached his mid-20s, Werner Heisenberg was no longer just a promising student. He was the bearer of a new vision of reality, one that blurred the line between knowledge and mystery, between science and philosophy. The intellectual foundation laid in his youth had now matured into a worldview that would shape the rest of his life. In the quiet moments after a lecture or a late-night discussion with colleagues, Heisenberg often reflected on how far he had come. He once remarked that the path of discovery is a journey inward as much as outward. To understand the universe, one must first understand the self, the limitations of perception, the biases of the mind, the yearning for certainty in an uncertain world. That introspection became the ethical and philosophical core of his later work. The story of Heisenberg's early life is, At its heart, the story of preparation. Every book he read, every question he asked, every conversation with mentors and friends shaped the mental landscape from which his discoveries would emerge. It reminds us that genius is not born in isolation but cultivated through curiosity, struggle, and reflection. And so, as the young physicist stood on the eve of his greatest discoveries, the echoes of his past were all around him, the voice of his father reading Greek philosophy, the memory of mountain air filling his lungs, the long nights of calculation under dim light. These were not just memories, they were the foundations of a worldview that would forever change our understanding of existence. In the end, the boy from W. Rosberg had become a man who dared to question the nature of reality itself. His early life was not just a prelude to discovery, it was a testament to the power of the human spirit, to dream, to doubt, and to see beyond the visible. From that foundation rose the mind that would one day reveal the uncertain, beautiful, and mysterious order that lies at the heart of everything. In the mid-1920s, a silent storm was brewing in the world of physics. The old order, the Newtonian view of a predictable, clockwork universe, was cracking under the weight of new discoveries. The atom, once thought to be the smallest indivisible unit of matter, had become a mystery box of contradictions. Light, which classical theory had long described as a wave, now behaved like a stream of particles. Electrons, supposedly circling the nucleus like tiny planets, refused to obey the laws that governed the celestial heavens. It was as if the universe had two faces, one that appeared orderly and continuous to the human eye, and another, deep beneath the surface, that shimmered with unpredictability. Werner Heisenberg stood at the center of this growing confusion. He was young, full of energy, and unafraid to challenge the impossible. By 1924, he had already gained a reputation among physicists as a bold thinker, someone who approached problems not with preconceived models but with fresh, intuitive insight. To him, physics was not about explaining what things are, but about describing what we can know about them. That distinction, subtle yet revolutionary, would soon become the cornerstone of a new kind of science. The existing atomic theories at the time were elegant but incomplete. Niels Bohr's model, which pictured electrons orbiting the nucleus in quantized energy levels, had explained the hydrogen atom's spectral lines but failed miserably for more complex atoms. The mathematics grew chaotic, the predictions inconsistent. Even Einstein's theories of relativity, magnificent as they were, offered no help here. The microscopic world was refusing to be tamed by the logic of the macroscopic. It was as if nature was playing a game, one that defied all rules of common sense. Heisenberg, restless and fascinated, decided to start from scratch. He resolved to rebuild atomic theory, not from assumptions about invisible particles, but from things that could actually be measured. This was a radical decision. For centuries, physicists had relied on mental pictures, tiny orbits, spinning spheres, invisible trajectories, to make sense of the unseen. But Heisenberg decided to abandon all imagery. If something could not be observed directly, he would leave it out of the theory. It was a philosophical leap as much as a scientific one. In June 1925, exhausted by hay fever and years of academic pressure, Heisenberg retreated to the island of Helgoland in the North Sea. The island, windswept and isolated, was far removed from the chaos of the cities and the noise of the world. The sea air cleared his mind, and the endless rhythm of waves seemed to mirror the mathematical order he sought. Here, among the gulls and cliffs, he finally found the silence he needed to think. Each day, he would walk along the coast, notebook in hand, reflecting on the failures of previous models and the strange beauty of quantum behavior. The key to the mystery, Heisenberg realized, lay in the spectral lines of atoms, the specific frequencies of light emitted when electrons changed energy levels. Those frequencies could be measured precisely, even if the underlying motion of the electrons could not. What if, he thought, the true essence of atomic behavior was not in the imagined path of electrons, but in the relationships between these measurable quantities? It was a bold thought. Physics should be based not on what we think is happening, but on what we can observe. He began to express the data in tables, arranging quantities like frequencies and intensities in ways that reflected how they interacted. Each transition between atomic states was represented not by a picture but by a mathematical relation. As he wrote, the mathematics took on a life of its own. The symbols began to multiply and intertwine, producing strange results. Unlike ordinary numbers, these new quantities did not commute, meaning that if you multiplied them in one order, you got a different answer than if you reversed the order. This was astonishing. In classical mathematics, order never mattered. 2 times 3 was the same as 3 times 2. But in the mathematics Heisenberg had stumbled upon, order did matter. It was as though nature itself was telling him that measurement and observation were not neutral acts, that the sequence of how one probed reality could change the outcome. The rules of the visible world had broken down, and a new logic had emerged in their place. Heisenberg worked feverishly, oblivious to everything around him. The days and nights blurred together in a rhythm of calculation and revelation. When the equations began to fit, when the pieces started to make sense, he knew he had found something monumental. The mathematics described the spectral lines with astonishing accuracy. He had built a new kind of mechanics, one that operated not with tangible orbits, but with arrays of abstract numbers. When Heisenberg returned to Göttingen, he presented his findings to Max Born, his mentor and one of the most brilliant mathematical physicists of the era. Born was stunned by the audacity of Heisenberg's approach. He realized that the strange arrays of numbers Heisenberg had created were actually matrices, mathematical structures that had existed in pure mathematics, but had never before been applied to physics. Born, with the help of his assistant Pascal Jordan, began to refine and formalize Heisenberg's discovery. Together, they published a paper that would forever change the landscape of science. On quantum mechanics. It was the birth of a new framework, matrix mechanics, the first complete formulation of quantum mechanics in history. The paper was dense, abstract, and unlike anything physicists had ever seen. There were no orbits, no trajectories, no visual models, only algebraic relations and probabilities. Many readers found it bewildering, even incomprehensible. But a few, those who understood its implications, recognized that physics had entered a new era. Heisenberg's matrix mechanics was not just a technical breakthrough, it was a philosophical earthquake. It declared, in essence, that the fundamental reality of nature could not be described in classical terms. What we observe depends on how we observe it. The act of measurement is not passive but active, it shapes the very thing being measured. This idea, though mathematical in its origin, had profound implications for how humans understood reality itself. At first, the scientific community was divided. Some hailed Heisenberg as a genius, others dismissed his ideas as abstract nonsense. Erwin Schrödinger, working independently, was developing a different approach, wave mechanics, based on continuous functions rather than discrete matrices. For a time, it seemed as though physics had split into two warring camps, the mathematicians on one side and the wave theorists on the other. Heisenberg himself was calm amid the controversy. He believed that both approaches described the same physical truth, just in different languages. His intuition proved correct. Within a year, Schrödinger demonstrated the equivalence between his wave mechanics and Heisenberg's matrix mechanics. The apparent contradiction resolved into harmony. The new quantum mechanics, born from Heisenberg's insight on a lonely island, had united mathematics and physics in a single framework that could predict the behavior of atoms with extraordinary precision. But beneath that triumph lay something deeper, something unsettling. The equations of quantum mechanics did not describe certainty. They described probabilities. They told physicists not where a particle is, but where it might be if observed. For the first time in history, science had to admit that knowledge of nature could never be complete. The universe, at its most fundamental level, was not deterministic but statistical. To Heisenberg, this was not a failure, it was revelation. He understood that uncertainty was not a gap in knowledge, but a principle of existence. His mathematical formulation reflected that truth. The non-commuting matrices symbolized the impossibility of knowing two complementary properties, like position and momentum, at the same time with perfect accuracy. Though he had not yet articulated the famous uncertainty principle, its spirit was already present in the equations. The birth of quantum mechanics was thus not just a scientific milestone, but a philosophical awakening. It challenged centuries of belief in an objective, observer-independent reality. It forced humanity to see that observation and existence were intertwined, that reality might depend on the act of being measured. For Einstein, this was deeply unsettling. For Heisenberg, it was liberating. He saw in the quantum world not chaos, but a new kind of order, one that embraced ambiguity as part of the truth. As the news of Heisenberg's discovery spread, it ignited a revolution across Europe. Physicists flocked to Copenhagen, Göttingen, and Zurich to discuss the new quantum mechanics. The old guard, raised on determinism, struggled to accept the new vision. But the younger generation, Pauli, Dirac, Jordan, embraced it with excitement. They sensed that science was undergoing not just a shift in knowledge but a shift in worldview. In seminar rooms and coffeehouses, arguments raged late into the night. Could reality truly be statistical? Was the universe fundamentally uncertain? Could mathematics describe existence without picturing it? These were not just technical questions, they were existential ones, and at the heart of them stood Heisenberg, calm and thoughtful, the quiet architect of the quantum revolution. Looking back, one can see how everything in his early life had prepared him for this moment. His grounding in philosophy allowed him to question assumptions that others took for granted. His comfort with abstraction allowed him to think without needing a picture. His deep respect for beauty and simplicity guided his mathematics. In the storm of uncertainty, he had found clarity, not by resisting the chaos, but by accepting it. The birth of quantum mechanics was not an event that happened in a single night. It was the culmination of years of intellectual struggle, collaboration, and courage. But that night on Helgoland, when Heisenberg looked up from his papers and realized that his equations worked, that they captured nature's strange behavior without contradiction, that was the moment the world changed. In that quiet room, as the sea winds howled outside, the foundations of classical reality crumbled, and a new vision of the universe was born. When Heisenberg finally sent his manuscript to Zeitschrift für Physik, he had no idea how history would remember that work. To him, it was not an act of revolution, but of necessity. Nature had spoken in riddles, and he had simply learned to listen in the right language. Yet what he had written would ripple across time, shaping technology, philosophy, and human understanding for generations to come. In that act of creation, Heisenberg had not merely solved a problem, he had redefined what it means to know. In the following years, Heisenberg's matrix mechanics began to gain recognition, but acceptance was far from immediate. His ideas, though brilliant, were not easily digestible, even for some of the most capable minds in physics. The concept that the fundamental elements of reality could not be represented in traditional terms, that the precise trajectories of particles could not be directly described, was deeply unsettling. Many physicists, trained under the deterministic elegance of Newton and Einstein, found it difficult to accept that nature could be governed by a mathematics that refused to be visualized. Yet, it was precisely this abstractness that gave Heisenberg's formulation its strength. It captured the hidden, statistical essence of the quantum realm, one where particles no longer followed predictable paths, but existed as patterns of probability, governed by the language of matrices. Heisenberg's 1925 paper, modest in appearance, marked the dawn of a new era. When Max Born and Pascual Jordan joined him in refining his ideas, they created a more complete form of matrix mechanics. The collaboration between these three minds became one of the most productive partnerships in early quantum theory. Born's mathematical insight, combined with Heisenberg's physical intuition, gave rise to a framework that could predict experimental results with astonishing accuracy. It explained the spectra of atoms, the behavior of electrons, and the stability of matter. Still, it was so alien to the physicists of the time that only a few could fully grasp its implications. Meanwhile, in a different corner of Europe, Erwin Schrödinger was developing another version of quantum mechanics based on wave equations. His method used smooth, continuous functions rather than matrices. When Schrödinger's results began to appear, many physicists felt relieved. They could visualize waves more easily than abstract grids of numbers. Even Schrödinger himself declared that his version of quantum mechanics was free from the obscurities of Heisenberg's matrices. But when the two approaches were compared, they turned out to be mathematically equivalent. Nature, it seemed, could be described in more than one language. What mattered was not the visual comfort of a theory, but its ability to reveal truth. Heisenberg, though initially doubtful of the wave interpretation, eventually accepted that Schrödinger's method was simply a different window into the same quantum world. The years between 1925 and 1927 were among the most intense in the history of science. Heisenberg, still in his mid-20s, found himself at the center of a revolution that was dismantling centuries of classical thought. Under the mentorship of Niels Bohr, he spent long nights in Copenhagen discussing the philosophical implications of quantum theory. The debates were not merely about equations, they were about reality itself. What does it mean to say that an electron exists at a certain place? Can something be both a wave and a particle at the same time? Heisenberg's restless intellect pushed him beyond mathematics into the realm of meaning, where science and philosophy intertwined. Bohr's Institute in Copenhagen became the heart of this new physics. Young researchers from across the world came there to exchange ideas, debate, and challenge one another. The air was electric with discovery. Heisenberg's close relationship with Bohr was both inspiring and demanding. Bohr was a man of great patience and philosophical depth, while Heisenberg was impulsive, analytical, and occasionally defiant. Yet their differences created balance. Together, they shaped what would later be called the Copenhagen interpretation, a profound understanding of how quantum phenomena should be viewed. By 1926, Heisenberg's work had gained international attention. He was invited to lectures, conferences, and universities that once dismissed him as too radical. His ideas were no longer fringe, they were the foundation of modern physics. Still, Heisenberg remained cautious. He knew that what he had uncovered was not just a new branch of physics, but a new way of thinking about reality. It required a shift in how humanity perceived nature, not as something predictable and mechanical, but as something probabilistic and dynamic. During these transformative years, Heisenberg's personal life also reflected the chaos of his intellectual journey. The world outside the laboratory was turbulent. Europe was still recovering from World War I, and political tensions simmered beneath the surface. Yet, within this uncertainty, Heisenberg found a kind of harmony. The mathematical precision of his theories gave him a sense of order that the external world could not provide. Each equation was a way of bringing meaning to chaos, a bridge between human understanding and the mysterious workings of the cosmos. The correspondence between Heisenberg and other physicists of the time reveals the emotional weight of this discovery. Many letters show moments of doubt, confusion, and exhilaration. Heisenberg often admitted that he himself was astonished by the implications of his equations. The idea that reality could not be fully known, that nature placed a fundamental limit on human knowledge, was both beautiful and terrifying. But Heisenberg was not content with mystery alone. He wanted to understand the reason behind this limitation, to uncover whether uncertainty was a flaw of perception or a property of existence itself. This inner conflict, this struggle between intuition and abstraction, became the driving force behind his next great leap. In the late 1920s, he began to explore the deeper meaning of his theory. How could one interpret the physical significance of these strange, invisible matrices? What did they say about the universe itself? Through long nights of reflection and calculation, Heisenberg began to see that his matrix mechanics hinted at something far greater, a truth that extended beyond physics into the nature of reality. By now, the young physicist who once sought to solve the riddles of atomic spectra had become the leading voice of a global revolution in science. The quantum world he helped uncover was unlike anything humanity had ever encountered. It was a realm where observation changed outcomes, where particles behaved like ghosts until measured, and where certainty dissolved into probabilities. Yet through all its strangeness, Heisenberg's discovery brought a deeper understanding of nature's harmony. The transition from classical mechanics to quantum mechanics marked one of the greatest intellectual transformations in human history. For Heisenberg, it was not merely a scientific revolution, it was a philosophical awakening. He had taken the first steps into a domain where mathematics, philosophy, and the limits of human perception merged into one. It was a journey that would soon lead him to one of the most profound realizations in all of science: that uncertainty was not a sign of ignorance but a fundamental law of the universe itself. As the 1920s drew to a close, Heisenberg's name had become synonymous with quantum theory. His achievements were recognized with growing admiration, and he received invitations from leading institutions across Europe. Yet, even in success, Heisenberg remained reflective. He once remarked that the task of the physicist was not to describe nature as it is, but to describe what we can say about nature. This subtle statement captured the essence of his philosophy, that our knowledge of reality is always filtered through observation, and that observation itself alters what is observed. Heisenberg's discovery laid the foundation for the next century of technological progress. The quantum mechanics he built would one day give rise to transistors, computers, lasers, and countless innovations that define modern civilization. But beyond its practical achievements, his theory carried a timeless message. It reminded humanity that the universe cannot be fully captured by logic alone. There is always a mystery at its core, a veil that cannot be lifted entirely, no matter how advanced our instruments or how precise our mathematics. In the quiet moments after lectures and debates, Heisenberg would sometimes reflect on the journey that had brought him here. From the starry nights of his youth in Munich to the intense discussions in Copenhagen, every step had been guided by the same question: what is the true nature of reality? The answer he found was both humbling and liberating. The universe was not a machine, it was a living, dynamic field of probabilities and possibilities. In discovering this truth, Heisenberg had not only changed the course of physics, but had also reshaped the boundaries of human thought. By the end of the decade, Werner Heisenberg stood at the pinnacle of a scientific revolution, yet the greatest discovery was still to come: the realization that uncertainty, once seen as a weakness of human knowledge, was in fact the deepest expression of nature's perfection. His next step would forever alter the way humanity perceives the world, transforming physics into a mirror that reflects both the mystery of the cosmos and the limits of our understanding. In the spring of 1927, the world of physics stood on the edge of revelation. A young German physicist named Werner Heisenberg, barely in his mid-20s, sat in a small room in Copenhagen, his desk scattered with sheets of paper filled with complex equations. Outside, the city was quiet, wrapped in a light mist, as though nature itself was waiting for the moment when the boundaries of knowledge would shift forever. Heisenberg had been wrestling with an idea that both fascinated and tormented him: a realization that something fundamental about reality could never be known with absolute precision. For years, he had been exploring the strange behavior of atomic particles, entities so small that they defied all common sense. In the classical world of Newton and Einstein, every object followed predictable paths. If you knew the position and velocity of something, you could, in theory, predict its future indefinitely. But in the quantum world, where electrons danced around atomic nuclei like restless spirits, that clarity vanished. When Heisenberg tried to describe their behavior using mathematics, Something unexpected appeared in his calculations, a limitation not caused by human error or poor instruments, but embedded within nature itself. The idea was shocking. The more precisely one tried to measure a particle's position, the less precisely one could know its momentum, and vice versa. This wasn't a technical problem or a temporary gap in knowledge. It was a law of nature. Heisenberg had discovered a fundamental truth that shattered the illusion of determinism. The universe, at its core, was uncertain. In those days, the idea of uncertainty was almost unthinkable to most scientists. The great success of classical physics had given humanity confidence that the universe was a perfect, clockwork mechanism, predictable, measurable, and complete. Every cause had a corresponding effect, and with the right equations, the future could be calculated like the ticking of a well-made watch. Heisenberg's discovery didn't just challenge that belief, it dismantled it. The world was not made of definite things moving in precise paths, but of probabilities, of possibilities that existed only until observed. The discovery came to Heisenberg not in a moment of sudden inspiration, but through nights of relentless thought and mathematical struggle. He had been working on understanding the way electrons scattered light, a problem that had long puzzled physicists. To describe the motion of these particles, he tried to apply classical ideas, but they simply didn't fit. The more he calculated, the clearer it became that the very act of measuring an electron's position changed its momentum. Observation itself disturbed the system being observed. This paradox seemed almost philosophical. How could nature hide its truth behind a veil that deepened the more you tried to lift it? Heisenberg turned this paradox into principle. He realized that uncertainty wasn't the result of clumsy instruments or lack of precision. It was intrinsic to the nature of things. There was a boundary beyond which reality could not be pinned down, a limit built into the structure of existence. When he finally expressed it mathematically, he wrote the now famous relation dx/dp=4, a simple looking equation that carries profound meaning. It states that the product of the uncertainty in positions x and the uncertainty in momentum λ can never be smaller than a fixed quantity. Planck's constant divided by 4. That tiny constant, first introduced by Max Planck in 1900, had already revolutionized physics by revealing that energy comes in discrete packets called quanta. Now, in Heisenberg's hands, it gained a new role as a symbol of the fundamental limits of knowledge. The equation meant that the universe does not allow absolute precision. The more you try to fix one property, the other slips away like sand through your fingers. Heisenberg's uncertainty principle did more than challenge the foundations of classical physics. It redefined them. It declared that the very act of observation alters what is being observed. In the quantum world, the observer and the observed could no longer be separated. To measure is to interfere, and to interfere is to change the outcome. This revelation blurred the line between objectivity and perception. Reality, it seemed, was not something entirely independent of us. It existed in a delicate interplay between the system and the observer. When Heisenberg shared his findings with Niels Bohr, the great Danish physicist immediately grasped their significance. Bohr, who had long been searching for a coherent interpretation of quantum mechanics, recognized in Heisenberg's principle the key to understanding nature's duality. The electron was neither a particle nor a wave, but something that could behave as either, depending on how it was observed. The world was no longer built from solid, predictable entities, but from possibilities that solidified only when measured. This idea was as philosophical as it was scientific. It suggested that reality is not fixed but probabilistic, not objective but contextual. To Heisenberg, this was not a failure of science but an evolution of understanding. For centuries, humanity had assumed that precision and predictability were the ultimate measures of truth. But the quantum world told a different story. One where the deeper you looked, the more reality dissolved into uncertainty. The emotional weight of this discovery cannot be overstated. For Heisenberg, it was both a triumph and a torment. He had solved one of the great mysteries of physics, yet he had also opened a door to a world that seemed to defy logic. The certainty that had guided generations of scientists was gone. In its place stood a strange, beautiful, and unsettling truth: that nature itself was fundamentally indeterminate. In his notebooks, Heisenberg often reflected on the philosophical meaning of his principle. He saw it not as a limitation of knowledge, but as a reflection of the harmony between the human mind and the natural world. He wrote that we could never see the path of an electron because such a path does not exist in the way we imagine it. The world of atoms does not follow human intuition. It follows its own subtle logic, one that blends chance with necessity. When Heisenberg first presented his findings publicly, reactions were mixed. Some physicists were stunned, others skeptical. To those trained in the traditions of Newton and Einstein, the idea that the universe contained intrinsic uncertainty seemed almost heretical. Even Einstein himself resisted it fiercely, believing that nature must obey deterministic laws. But to Heisenberg, uncertainty was not chaos. It was order of a new kind, an order based on probability rather than certainty. This distinction was crucial. The uncertainty principle did not mean that everything was random. It meant that at the quantum level, nature behaves statistically. While one cannot predict the exact outcome of a single event, one can predict the distribution of outcomes over many events with astonishing accuracy. Quantum mechanics, despite its apparent strangeness, became the most precise theory in the history of science. Heisenberg's discovery also carried profound implications beyond physics. It touched philosophy, logic, and even human psychology. It suggested that our desire for absolute certainty, whether in science, morality, or existence, might always be met by limits. The more we try to define something perfectly, the more we disturb its true nature. This was not just a law of atoms, but perhaps a metaphor for the human condition itself. In the years following 1927, the uncertainty principle became one of the cornerstones of modern physics. It guided new generations of scientists as they explored the quantum world. It became the foundation for wave mechanics, quantum field theory, and later, the strange and powerful technologies of the modern age: semiconductors, lasers, and quantum computers. Yet even as its applications multiplied, the philosophical questions it raised continued to echo. Heisenberg's insight revealed something profound about the relationship between knowledge and reality. It reminded humanity that the universe is not something to be conquered or mastered, but something to be understood in humility. The very fabric of existence is woven from uncertainty, and that uncertainty is what allows the universe to be dynamic, creative, and alive. Without it, there would be no change, no evolution, no life. For Heisenberg, the uncertainty principle was not just a scientific rule. It was a window into the soul of nature. It suggested that the cosmos is not a static machine, but a living tapestry of possibilities, each moment pregnant with potential. He often compared this view to the ideas of ancient philosophers, who believed that the essence of reality could never be grasped entirely, only experienced through its patterns. As he refined his thoughts, Heisenberg realized that uncertainty was not merely about what we cannot know. It was about what nature itself chooses to reveal. Every measurement, every act of observation, was a conversation between human consciousness and the physical world. And in that dialogue, the universe did not give up its secrets easily. It offered glimpses, fleeting, delicate, that pointed to a deeper harmony underlying the apparent randomness. In a letter to a friend, Heisenberg once wrote, "What we observe is not nature itself, but nature exposed to our method of questioning." This simple yet profound statement captured the essence of his revolution. It acknowledged that science, for all its power, is shaped by human perception. The questions we ask shape the answers we receive. Reality is not a detached object waiting to be examined, it is a partner in our pursuit of understanding. The uncertainty principle was not just a mathematical insight, it was a philosophical awakening. It forced humanity to reconsider what it means to know something. It suggested that knowledge is not about conquering nature, but about participating in its unfolding. Each observation is a meeting point between mind and matter, between the measurable and the mysterious. When Heisenberg finally presented his paper on uncertainty, it marked one of the defining moments in modern science. The world of physics would never be the same again. What began as a search for clarity in the motion of electrons had transformed into a revelation about the nature of reality itself. Heisenberg had shown that the universe was far more subtle than anyone had imagined, a place where certainty dissolves and mystery reigns supreme. In the quiet aftermath of his discovery, Werner Heisenberg found himself both celebrated and challenged. The uncertainty principle had burst into the scientific world like a thunderclap, reshaping not just physics but the very idea of what knowledge could mean. Yet, as the echoes of his revelation spread through the halls of universities and the pages of journals, it became clear that humanity was standing at the edge of something far greater, a redefinition of truth itself. Heisenberg had shown that the fabric of reality was woven with limits, that there were borders even the sharpest mind could never cross. But within those borders lay the beauty of creation, a universe built not on rigid laws alone, but on freedom, probability, and the dance of chance. In the late 1920s, Heisenberg often sat with Niels Bohr, discussing the implications of this new quantum world. Their conversations were as much philosophical as they were scientific. Bohr believed that the uncertainty principle captured something profound about existence, that reality does not exist in one definite state until we look at it. Before observation, the electron is not here or there, not moving fast or slow. It exists as a wave of possibilities. Only when we measure it does one of those possibilities become real. Heisenberg found this idea deeply intriguing. The act of observation did not simply reveal reality, it created it. To Heisenberg, this was more than an abstract notion. It was a direct confrontation with the human desire for control and certainty. For centuries, science had been about prediction, the dream that with enough data, one could foresee everything. The uncertainty principle tore down that dream. It replaced the clockwork universe with something more mysterious, something that breathed and changed, something that seemed almost alive. This new vision of nature drew mixed reactions. Some physicists embraced it with wonder, seeing in it the poetry of the cosmos. Others resisted fiercely. Albert Einstein was among the most vocal skeptics. For him, the idea that the universe could be governed by probability rather than precise law was intolerable. God does not play dice with the universe, he famously declared. Heisenberg respected Einstein deeply, but saw the issue differently. He believed that nature was not chaotic, it was simply subtle. The dice were not a sign of randomness but of deeper order, one that could not be expressed in classical terms. In private letters, Heisenberg often wrote about the tension between determinism and freedom. He saw the uncertainty principle as a symbol of balance, between the known and the unknown, between measurement and mystery. It reminded him of ancient philosophy, of the Greek thinkers who saw the universe as a harmony of opposites. In his own words, he wrote, "What we observe is not nature itself, but nature exposed to our method of questioning." He understood that knowledge was not the same as reality. It was a reflection of how we engage with reality. As the scientific community grappled with this new understanding, Heisenberg's principle began to influence every corner of modern thought. Philosophers pondered its meaning, poets drew inspiration from its mystery, and theologians debated its implications for free will and divine order. The uncertainty principle became more than a scientific statement. It became a metaphor for the human condition. We live in a world where certainty is an illusion, where every decision and observation changes the outcome, where life itself unfolds in probabilities rather than guarantees. Heisenberg's life during these years was one of deep contemplation and intense work. He continued refining the mathematics of quantum theory, building bridges between his matrix mechanics and Schrödinger's wave mechanics. Together, These frameworks formed the complete foundation of quantum mechanics, a theory that would go on to describe every atom, molecule, and particle in existence. Yet, behind the equations, Heisenberg saw something deeply human, a reflection of our own limitations and aspirations. He once described his experience of discovery as standing on the edge of a great sea of uncertainty, with only faint lights in the distance guiding him forward. Each calculation, each insight, was like a step into the unknown, and though the path was often dark, it led to moments of breathtaking clarity, glimpses of the cosmic order that lay beyond the reach of certainty. In lectures and writings, Heisenberg began to explore how uncertainty shaped not just science but the nature of thought itself. He argued that the limits of measurement were not flaws but features of reality. Just as the human eye cannot see beyond the visible spectrum, the human mind cannot penetrate beyond certain boundaries of knowledge. These boundaries, however, were not barriers to progress. They were what made discovery possible. Because there are things we cannot know completely, there will always be new questions to ask, new mysteries to explore. As he matured, Heisenberg's thinking grew more philosophical. He saw parallels between quantum uncertainty and the unpredictability of human life. Just as one cannot determine an electron's exact position and momentum at the same time, one cannot predict the exact path of a person's destiny. Every choice, every observation changes the course of what comes next. The uncertainty principle became, in his mind, a universal truth, not just of physics but of existence itself. The public response to his work was equally remarkable. Newspapers and journals across Europe hailed Heisenberg as a genius who had shaken the foundations of science. His discovery was awarded the Nobel Prize in Physics in 1932, though the principle itself had already become legendary by then. Yet, even with recognition, Heisenberg remained humble. He often reminded his audiences that his work did not provide answers to every question. It simply revealed that nature's language was more mysterious than we had imagined. In classrooms, professors began teaching the uncertainty principle to a new generation of students. Young physicists, inspired by Heisenberg's ideas, went on to develop quantum field theory and particle physics. The principle became a guiding compass for all modern research into the smallest scales of nature. It underpinned the discovery of the atom's structure, the behavior of subatomic particles, and even the mechanisms behind nuclear energy and quantum computing. What had started as a theoretical realization in a quiet Copenhagen room became the cornerstone of technologies that would one day change civilization. But for Heisenberg, the uncertainty principle always remained something spiritual as well as scientific. He once said that the more he studied physics, the more he felt drawn toward questions of philosophy and metaphysics. Science, he believed, could not be separated from the human spirit that seeks to understand it. The boundary between physics and philosophy was, in his view, as fluid as the boundary between particle and wave. He was deeply moved by how the uncertainty principle echoed the paradoxes found in ancient wisdom, in Taoism, where opposites coexist in harmony, in the philosophy of Kant, where perception defines experience, and even in the writings of Goethe, where knowledge and mystery are intertwined. For Heisenberg, the principle was a bridge between modern science and timeless truth, a reminder that the universe is not something to be dissected and conquered, but something to be lived with and wondered at. Even as decades passed, Heisenberg's discovery continued to provoke new debates. Some physicists sought to reconcile quantum uncertainty with Einstein's desire for a deterministic universe, leading to theories of hidden variables and quantum realism. Others embraced Heisenberg's interpretation, seeing in it a profound freedom, a world where possibility is fundamental and certainty is an illusion. Every experiment confirmed his mathematics, yet the philosophical implications remained as elusive and provocative as ever. Heisenberg himself often smiled at the continuing debates. To him, the confusion was a sign that his discovery had touched something essential. He once remarked that if quantum mechanics did not shock you, then you had not truly understood it. That shock, that sense of wonder mixed with bewilderment, was what kept science alive. It reminded humanity that the pursuit of knowledge is not about reaching an endpoint, but about continually expanding the horizon of what can be known. In his later years, Heisenberg reflected on his journey with quiet gratitude. He saw his uncertainty principle not as an obstacle to truth, but as the purest expression of it. The universe, he believed, was not designed to yield its secrets easily. It invited us to participate, to question, to imagine. Uncertainty was not a sign of weakness. It was the heartbeat of reality itself. He often returned to the thought that the world we perceive is only one of many possible worlds, that beneath the surface of what we see lies an infinite sea of potential. Every observation collapses that sea into one moment, one event, one fact, but the possibilities never vanish. They remain, waiting for the next act of measurement, the next spark of consciousness. In this way, Heisenberg saw a profound unity between physics and life. Every moment of existence was an unfolding of probabilities shaped by choice, observation, and chance. By the end of his life, Heisenberg had come to see the uncertainty principle as more than a discovery. It was a philosophy of being. It taught that limits and freedom are intertwined, that knowledge and mystery coexist, and that the pursuit of truth is endless. His principle had begun as an attempt to explain atomic behavior, but it had grown into a universal insight into the nature of existence itself. In the vast story of science, Heisenberg's revelation stands as one of humanity's greatest turning points. It taught us that the universe is not a machine, but a masterpiece of subtlety. It reminded us that perfection does not mean precision, and that uncertainty is not ignorance. It is the space where all creation begins. Even now, nearly a century later, every scientist who peers into the quantum world carries a piece of Heisenberg's legacy. Every time we measure, every time we observe, we are reminded of that delicate balance. That to see something is to change it, and that reality itself is an unfolding conversation between knowledge and mystery. In the end, the uncertainty principle was not just a discovery that defined physics, it was a mirror held up to the human spirit. It showed us that even in the smallest particles, the universe whispers a truth we all must face. That life, like the quantum world, is filled not with certainties, but with infinite possibilities. And in that uncertainty lies the true beauty of existence. As Heisenberg's uncertainty principle began to spread through the scientific community, it sparked both fascination and controversy. The idea that the more precisely one knows the position of a particle, the less precisely one can know its momentum, was not just a technical statement, it was a philosophical earthquake. For centuries, science had been built on the belief that, with perfect instruments and enough knowledge, humans could predict everything that happens in the universe. Heisenberg's principle shattered that dream. It told the world that uncertainty is not a flaw of our tools, but an inseparable part of nature itself. Reality, it seemed, did not like to be pinned down. In laboratories and universities across the world, this discovery ignited deep discussions about what it truly meant to know something. Could a particle even be said to have a definite position before it is measured? Was reality fixed and objective, or did it somehow depend on observation? These questions were no longer philosophical curiosities, they were the heart of modern physics. Heisenberg's principle showed that when we look into the atomic world, our act of observing changes what we see. The very process of measurement disturbs the system, making complete certainty impossible. This revelation redefined what science could claim about the universe. Einstein, however, refused to accept such a view of reality. To him, the universe was governed by laws that were exact and elegant. The notion that nature played dice, as Heisenberg and Bohr seemed to suggest, was unacceptable. He famously declared, "God does not play dice with the universe." But Heisenberg, with calm conviction, believed otherwise. He argued that quantum mechanics did not deny order, it merely revealed that this order existed in probabilities rather than certainties. The universe, he said, is not chaotic, It simply follows rules that are subtler than human intuition. The clash between Einstein and Heisenberg was not one of hostility but of vision. Einstein sought a deeper, deterministic theory that would restore predictability, while Heisenberg and Bohr embraced the strange truth that uncertainty was woven into the fabric of existence. Their debates became legendary, filled with passion and respect. Einstein would propose thought experiments to challenge quantum mechanics, imagining ways to measure particles without disturbing them. Each time, Heisenberg and Bohr would find that the uncertainty principle held firm, defying every attempt to outsmart it. These exchanges were more than scientific arguments, they were explorations of how deeply human perception could reach into the mysteries of creation. For Heisenberg, the principle of uncertainty was not a sign of weakness, but a statement of humility before nature. It taught that there are boundaries to what can be known, and that within those boundaries lies a profound beauty. The quantum world, far from being unpredictable chaos, operates under its own consistent laws that reveal patterns only through probability. This understanding required a new kind of thinking, one that accepted the coexistence of opposites: certainty and uncertainty, order and chance, knowledge and mystery. As experiments began to confirm his theory, the scientific community slowly shifted. What once seemed impossible became accepted as the new foundation of physics. The uncertainty principle explained phenomena that had long puzzled researchers: why electrons in atoms do not crash into the nucleus, how particles tunnel through barriers, and why light behaves as both wave and particle. It provided a framework through which the quantum world could finally make sense, even if it defied classical intuition. The broader implications of Heisenberg's discovery extended beyond physics. Philosophers, theologians, and artists began to draw meaning from it. To them, the uncertainty principle reflected the human condition, a reminder that absolute truth is elusive, and that understanding often emerges from the unknown. It suggested that the act of observation, whether in science or in life, changes what is being observed. In this way, Heisenberg's work transcended mathematics. It became a meditation on existence itself. The public, too, was captivated by the mystery of quantum mechanics. Newspapers and lectures spoke of the strange new world where reality flickered between certainty and probability. For many, it was unsettling to think that the universe was not a perfectly predictable machine, but a dynamic field of possibilities. Yet, for others, it was exhilarating, a vision of nature that was alive, creative, and endlessly mysterious. Heisenberg himself continued to explore the philosophical depths of his theory. He wrote about the unity of mind and nature, arguing that human consciousness and the physical world are intertwined. The observer, he said, is not separate from what is observed. This insight laid the foundation for later interpretations of quantum mechanics, where observation plays an essential role in shaping reality. It was a bold idea that blurred the line between science and philosophy, inviting humanity to see knowledge not as domination over nature, but as participation within it. By the time the dust of debate settled, the uncertainty principle had become one of the cornerstones of modern physics. It was no longer seen as a limitation, but as a guiding law that described how the universe truly behaves at its most fundamental level. Heisenberg had shown that the microcosm of atoms operates by rules far stranger and more profound than anyone had imagined. His discovery not only redefined science, but also reshaped humanity's understanding of its place in the cosmos. The principle that once confused even Einstein ultimately revealed a deeper harmony, a balance between what can be known and what must remain uncertain. In that balance lies the elegance of the quantum world, a universe that is both mysterious and meaningful. Heisenberg's insight, born from abstract mathematics and deep contemplation, became a timeless reminder that reality is not always what we expect, but it is always more wondrous than we can imagine. The uncertainty principle had not only transformed physics, but also reshaped the scientific imagination of an entire generation. Yet, Heisenberg's journey did not end with theory. It expanded into the vast philosophical and moral questions that arose from his discovery. As he delved deeper into the quantum world, he began to realize that the equations he had written were not merely mathematical tools, but reflections of how human beings interact with nature. The observer was no longer a detached spectator. The act of measurement itself altered the outcome. This realization carried profound implications for how humanity understood truth, knowledge, and existence. In the late 1920s, as the quantum revolution continued to unfold, Heisenberg stood alongside the giants of his era: Bohr, Einstein, Schrödinger, Dirac, and Born, each contributing to the strange, beautiful puzzle of reality. Yet Heisenberg's own perspective was unique. He saw in quantum theory not chaos but harmony, a delicate balance between possibility and actuality, between what could be known and what must remain hidden. To him, uncertainty was not disorder, it was the rhythm of the cosmos, the breath of creation itself. This deeper meaning gave his work a philosophical weight that extended far beyond laboratories and equations. Heisenberg believed that physics had crossed a boundary where science met philosophy. The certainty of Newtonian laws, which once promised complete knowledge, had dissolved into a sea of probabilities. The world was no longer a mechanical clock, but a living system of relationships in which every act of observation changed the whole. This new worldview required humility, a recognition that the human mind, no matter how brilliant, could never grasp the totality of nature. Yet within that humility lay a new kind of freedom. By accepting uncertainty, humanity could finally approach the universe not as conquerors, but as participants in its unfolding mystery. Einstein, though respectful, remained troubled. He could not accept that God would play dice, and he continued to search for hidden variables, deeper laws that might restore determinism to physics. But the experiments that followed would only strengthen Heisenberg's position. The famous double-slit experiment, for instance, revealed that particles behaved differently when observed, as if awareness itself influenced the outcome. It was as if the universe responded to being seen. For Heisenberg, this was not a flaw in understanding, it was the very essence of existence. The observer and the observed were bound together in an inseparable dance. The implications of this new understanding rippled far beyond physics. Philosophers began to question the nature of reality itself. Was the world, there, independent of us, or was it in some way co-created by our perception? The quantum revolution opened a doorway to ancient questions of mind and matter, unity and division. Heisenberg himself often drew parallels between modern science and ancient philosophy. He saw echoes of Plato's ideal forms in the mathematical patterns of quantum mechanics, and glimpses of Eastern mysticism in the interconnectedness of all things. In this way, his science became a bridge between cultures and eras, between logic and intuition. During the 1930s, as political tensions rose across Europe, Heisenberg found himself in a complex position. His fame had made him a national figure, but the world around him was descending into turmoil. The same mind that sought harmony in the quantum world was forced to witness the growing chaos of human conflict. He continued to teach and research, focusing on the unity of natural laws even as the unity of nations collapsed. Through it all, his belief in the deeper order of the universe never wavered. For him, science remained a form of hope, a reminder that beneath the surface of uncertainty, there was still meaning and coherence. Heisenberg's reflections on his work were deeply human. He often spoke about the responsibility of scientists, emphasizing that knowledge must be guided by wisdom. The quantum world had shown that the act of observation changes reality. In the same way, he believed that human choices shape the course of history. To know the world, therefore, was not enough. One had to understand the consequences of that knowledge. This moral dimension of his thinking would later influence discussions about nuclear physics, ethics, and the role of science in society. As the years passed, Heisenberg continued to refine his ideas, exploring how uncertainty operated not only in physics but in life itself. He saw parallels between the unpredictability of particles and the unpredictability of human existence. Just as no one could know both the position and momentum of an electron, no one could foresee the full consequences of their actions. Life, like nature, was not meant to be perfectly predictable. It was a field of possibilities, shaped by choice, chance, and consciousness. The uncertainty principle thus became more than a scientific discovery. It became a metaphor for the human experience. It taught that knowledge is always partial, that truth is approached but never possessed. It reminded humanity that the universe, despite its complexity, is not hostile to understanding but invites curiosity and wonder. For Heisenberg, this was the true reward of science, not the conquest of mystery, but communion with it. By the time Heisenberg's work was fully recognized, the world had changed forever. His ideas formed the backbone of quantum mechanics, influencing everything from chemistry to electronics, from cosmology to information theory. Yet even as his equations powered the engines of modern technology, their deeper meaning continued to inspire awe. Heisenberg had revealed a truth that transcended physics, that uncertainty is not the enemy of knowledge, but its companion. The quest for understanding, he believed, would always involve the unknown, and that was what made it worth pursuing. In the end, Heisenberg's legacy was not merely that of a brilliant physicist, but of a thinker who reshaped the way humanity sees itself. He had shown that the smallest particles of matter carry within them the greatest mysteries of existence. The universe, once thought to be a rigid mechanism, was now understood as a dynamic interplay of potential and realization, a living, breathing cosmos of endless possibility. Through his work, Heisenberg taught that truth is not found in absolute certainty, but in the eternal dance between what can be known and what must remain forever uncertain. As Heisenberg's ideas matured, their influence began to stretch far beyond the boundaries of laboratories and universities. His uncertainty principle had already altered the structure of physics, but now it began to alter the way humanity thought about knowledge itself. It suggested that reality was not a fixed stage on which events unfolded, but a living web of interactions where observer and observed could never be separated. This revelation marked the beginning of a new intellectual era. Scientists, philosophers, and even artists began to realize that the universe was not a static collection of things, but a dynamic process, constantly shaped by perception, measurement, and consciousness. In this period, Heisenberg became both a scientist and a philosopher. He started to see that the true power of quantum mechanics lay not only in its ability to predict outcomes, but in its challenge to human assumptions about existence. He often spoke about how the quantum world forces us to rethink what we mean by reality. In the microscopic world, particles do not have defined positions until they are observed. They exist in a state of probability, a cloud of potential. This was more than a scientific statement. It was a poetic truth about life itself. Everything in nature, Heisenberg realized, exists as possibility before it becomes actual. The universe is not built from solid objects, but from waves of potential that collapse into being through interaction and observation. This profound understanding carried spiritual undertones, though Heisenberg never intended to make religion out of science. What he sought was unity, the idea that the physical and metaphysical worlds are not separate, but deeply connected. He often found inspiration in ancient philosophy, drawing parallels between quantum theory and the teachings of Greek thinkers like Plato and Aristotle. To Heisenberg, quantum mechanics was a modern reflection of an old truth, that reality cannot be fully divided into mind and matter, for both are expressions of the same universal order. In his writings, he compared the probabilistic nature of the quantum world to the idea of potentiality in classical philosophy, the concept that everything that exists does so as both what it is and what it might become. As his reputation grew, Heisenberg's voice carried great weight. He became a leading figure not only in physics but in discussions about science's role in society. The world was rapidly changing, moving toward an age where technology, born from quantum discoveries, could shape the fate of nations. Atomic energy, quantum electronics, and nuclear research were emerging as the defining forces of the 20th century. Heisenberg understood that his work had opened doors that could lead to both creation and destruction. He spoke often about the moral responsibility that accompanies knowledge, the idea that scientists must remain aware of the ethical consequences of their discoveries. For him, uncertainty was not an excuse for moral confusion but a reminder of humility, a call for wisdom in the face of immense power. The Second World War cast a long shadow over his life. As Germany plunged into darkness, Heisenberg faced impossible choices. He remained in his country, attempting to preserve what he could of pure science amidst the rising tide of political corruption and war. His role in Germany's atomic research program would later become a subject of intense debate, but those who knew him understood that his devotion was always to understanding, not to destruction. Heisenberg himself once said that physics should be a bridge between nations, not a weapon to divide them. The same man who discovered the limits of certainty in nature now lived through an age when human certainty in ideology and power brought the world to the edge of ruin. After the war, Heisenberg dedicated much of his life to rebuilding the scientific and moral fabric of Europe. He became a leading voice in international cooperation, helping to restore communication among scientists separated by conflict. To him, the pursuit of knowledge was a universal human endeavor, transcending nationality and politics. His experiences deepened his belief that uncertainty is not a weakness, but a condition of growth. Whether in physics, society, or life, out of uncertainty, new understanding is born. Just as quantum particles exist in multiple states before being observed, humanity, too, holds infinite potential before choosing its path. Heisenberg's later reflections were deeply poetic. He described the world as a fabric of events, where energy, matter, and consciousness flow together in a seamless unity. He wrote that the atoms or elementary particles themselves are not real, they form a world of potentialities rather than one of things or facts. These words carried an echo of the mystics, suggesting that the essence of existence is not solid but relational, not fixed but unfolding. For Heisenberg, the discovery of uncertainty revealed not chaos but an underlying harmony, an order that is subtle, creative, and alive. His encounters with Einstein continued to haunt and inspire him. Though they disagreed, Heisenberg always spoke of Einstein with admiration. He saw in Einstein's struggle a reflection of humanity's desire for clarity and meaning. But Heisenberg believed that true understanding required embracing paradox, not escaping it. The universe was not designed to satisfy the human need for certainty, it was designed to challenge it, to keep curiosity alive. This tension, between knowing and not knowing, was, for Heisenberg, the heartbeat of both science and existence. By the final years of his life, Heisenberg had become a symbol of intellectual courage. His uncertainty principle had transformed into a philosophy of life, a way of seeing that embraced ambiguity as a source of strength. He showed that boundaries are not barriers but bridges between what we know and what we seek to discover. Through his work, humanity learned that even in uncertainty, there is structure, even in mystery, there is meaning. Heisenberg's legacy endures not merely in equations or scientific achievements, but in the wisdom that grew from them. He taught the world that the pursuit of truth is never about finding absolute answers, but about deepening our relationship with the unknown. The same principle that defined the motion of subatomic particles also defined the motion of human thought. Every discovery opens new questions, every observation changes the observer. In that endless exchange between knowledge and mystery lies the beauty of existence, the quantum heartbeat of the universe, where certainty fades, but wonder never ends. As Heisenberg reached the later stages of his life, the true magnitude of his discovery began to unfold before his eyes. What had started as a purely mathematical insight had grown into one of the deepest philosophical and scientific revolutions in human history. The uncertainty principle was no longer just a law of physics. It had become a lens through which humanity viewed the entire universe. Heisenberg saw his work echoed in the rise of quantum technology, in the development of nuclear physics, and in the philosophical discussions that sought to understand the limits of human perception. He had opened a door that could never be closed, a door that led into the very heart of reality, where mystery and knowledge intertwined. By the mid-20th century, quantum mechanics had become the foundation of modern science. Everything from semiconductors and lasers to atomic clocks and quantum computers owed its existence to the framework Heisenberg helped create. Yet, as the world celebrated these technological marvels, Heisenberg remained a man of reflection. For him, the true achievement of quantum mechanics was not in its applications, but in its message that reality is more subtle, more interconnected, and more alive than human reason can fully grasp. He often said that science, at its best, should bring us closer to wonder, not further from it. Heisenberg's uncertainty principle found new meaning in the post-war world, where humanity was struggling with the consequences of its own scientific power. The atomic bomb had shown that knowledge could both illuminate and destroy. Heisenberg, deeply aware of this, spoke often about the moral responsibility that comes with discovery. He urged young scientists to approach nature with humility, to remember that every experiment, every equation, carries ethical weight. His vision of science was not one of domination but of harmony, a dialogue with nature in which humans are participants, not masters. In his later writings, Heisenberg explored how the lessons of quantum physics extended beyond matter into the realm of consciousness. He believed that the act of observation, so central to his uncertainty principle, revealed something profound about the relationship between the human mind and the universe. Observation, he suggested, was not a passive act, but a creative one. The observer and the observed were partners in the unfolding of reality. This idea resonated with philosophers, mystics, and artists alike. It implied that human awareness is not separate from the cosmos, but woven into its fabric, shaping and being shaped by it in an endless exchange. Heisenberg often reflected on how the uncertainty principle mirrored life itself. In every human endeavor, love, art, science, morality, certainty is never absolute. The more we try to control outcomes, the more we realize that existence operates through balance and unpredictability. Just as a particle's position and momentum cannot both be known precisely, the course of a human life cannot be fully mapped. Each choice, each observation, collapses possibilities into reality. Life, like the quantum world, is a dance between potential and actuality. To Heisenberg, this was not cause for despair but a reason to embrace wonder. Uncertainty was not a void. It was the source of creation. The last decades of his life were devoted to teaching, writing, and contemplation. He sought to integrate his scientific insights with a broader understanding of nature and culture. He spoke about how modern science, in its deepest sense, does not contradict spirituality but enriches it. Both, he believed, are paths toward truth, different languages describing the same reality. Heisenberg saw in quantum mechanics a reminder of the ancient wisdom that the universe is one, that separateness is an illusion, and that knowledge is always incomplete. He viewed uncertainty not as chaos but as freedom, the breath of possibility that makes existence meaningful. When Heisenberg passed away in 1976, the world lost not only a great physicist, but one of its most profound thinkers. His ideas had reshaped the course of science and altered the philosophical landscape of the 20th century. The uncertainty principle became a symbol of humility in the face of the infinite, a reminder that no matter how much humanity learns, there will always be mystery at the core of reality. His work influenced generations of scientists who came after him, men and women who built quantum theory into the foundation of modern civilization. Every computer chip, every laser beam, every quantum experiment today carries an echo of his genius. Yet, beyond technology and theory, Heisenberg's legacy endures in the way he taught the world to think. He showed that knowledge and mystery are not enemies but partners. He taught that uncertainty is not the end of inquiry, but its beginning. The boundaries of the unknown, he believed, are not walls to be broken, but horizons to be explored. Through his work, he reminded humanity that science is not merely about control or prediction. It is a journey of discovery that mirrors the human spirit itself. Even now, decades after his death, Heisenberg's principle continues to inspire new generations to question the nature of existence. From quantum computing to cosmology, from philosophy to consciousness studies, his insight into uncertainty remains as relevant as ever. The quantum world he uncovered continues to whisper its message that every observation is an act of creation, every moment a choice between infinite possibilities. Heisenberg's story, in the end, is not just the tale of a scientist, but of a seeker, a man who dared to look beyond the boundaries of knowledge and found beauty in what could not be known. He gave humanity a new way of seeing the universe, one that blends precision with mystery, logic with wonder. His uncertainty principle stands as one of the great turning points in the history of human thought, a timeless truth about the nature of reality itself. And in that truth lies the profound message he left behind, that the universe, in all its uncertainty, is not something to be feared, but something to be cherished, because within its infinite possibilities lies the very essence of creation.